Hi, in this tutorial we're going to work with the map view as well as core location. So our example, we're going to be getting the longitude and latitude information of where you are located as well as the degree of accuracy. Now in a previous video we had looked at using a map kit in order to obtain the user's current location on a map. In this example, we'll be using both the map kit as well as the core location framework. So it's important to understand the difference between the two and how they work together. So the map kit, the map displays position-sensitive information and the user interface. Core location is about getting information about where you are, and then we take that information and give it to the map kit to show it to us on the map. So core location gets this data of longitude and latitude and then can display it on the map. Now in the other example, we were only able to find, when we wanted to pinpoint our location, it showed us that we were in Cupertino, California. But now we're going to be able to display a more accurate pinpoint of where you are located. And so how does it know where you are? How does core location know where you are? Well, there are three different ways that core location can determine your location. First is using GPS receivers. And so we're all familiar with GPS. It requires a clear sky, won't always work indoors or in tunnels. Sometimes even under a dense forest, you can have trouble getting a GPS signal. The second way is cell tower triangulation. And when a mobile device is switched on, it's constantly in contact with base stations surrounding it. So by knowing the identity of the cell phone towers, it's possible to figure out a physical location through different databases that contain the cell towers' identification information and their location. So this works indoors without the need for satellites. It's not as precise as GPS because it depends on the area that you're in. More densely populated areas with more towers will be more accurate, and areas with less towers will be less accurate. And then finally, it can find you through what's called Wi-Fi triangulation. So the device that you're using is connected to a Wi-Fi network, and it can check the service provider against a database to determine the location that's serviced by that provider. Now this is the least accurate. But since our simulator doesn't have a GPS or cell tower triangulation, it's figuring out where you are based on Wi-Fi triangulation. So that's why in this example, we're able to get a more geographically correct position of where you are, as opposed to the last example that I had for maps. Let me just pull that example up. So in this maps example, we had the find me and wants to use your current location. And it thinks we're in Cupertino, California. If this was run on an actual device that had GPS capability, then it would zero in on where you are. But since the simulator doesn't have a GPS, it's defaulting to Cupertino. In our application that we're building, it's going to be using a combination of GPS, cell tower, and Wi-Fi triangulation. And so through the Wi-Fi triangulation, it's going to get a closer picture of where you're located based on the Wi-Fi network that you're connected to. So to get started, I'm going to create a new project in Xcode. Okay, to create our new project, I'm going to choose a single view application and click Next. And my project name, I'm going to call this LBS, for short for location-based services. And I'm going to make sure my device family is set for iPhone. I'm not going to use storyboards since I only have one view controller. and I'm going to make sure Use Automatic Reference Counting is checked off. And I'll click Next to save my project. I'm just going to put it onto my desktop and then click Create. Now our application is going to use both the MapKit framework as well as core location. So in the project information summary screen, I'm going to scroll up to where we have the linked frameworks and libraries section. And I'm going to click the little plus sign to get a list of available frameworks. And I'm going to scroll down and first of all choose core location and add. And I'm also going to add the MapKit framework. So I'm going to click the plus sign again and come down and choose the MapKit and add. Now in my Files panel over to the side, you can see that both of these have been added. Now it didn't put it into the Frameworks folder, and that's okay. It doesn't have to be in there, but just to be organized, I'm going to select both of those and just drag them on top of that Frameworks folder so they're all in one place. And again, by adding frameworks into your project, this allows us to be able to access methods and properties that we didn't have access to before. So for example, the core location framework has a folder of headers, and these header files have defined different methods and properties that we have available to us in our application. So by Apple providing these to us, we don't have to write out a lot of code in order to implement this type of functionality. So now that we have the frameworks added, I'm going to go into my View Controller nib file, and I'm going to set up the user interface. And I'm going to add a few labels and a few text fields. So I'm going to have a label and then a matching text field for it. And we're going to have one for accuracy, longitude, and latitude. So I'm going to pause this and set up my interface. Okay, so I've just added labels for accuracy, longitude, and latitude. And then I have text fields that match each one of them, because what we're going to be doing is putting the values into these text fields. Next, we're going to use a map view. So I'm going to scroll down here and find the map view and drag that onto our interface. And I'm going to scale it out, make it larger. Okay, so the user interface is now set up. So now we can move on to setting up the header file. So I'm going to close out of the utility panel and go into the assistant editor, and we can set up our outlets. We're going to have an outlet for each of the different text fields and our map view. So I'm going to start by selecting the accuracy text field, and I'm just going to right click and drag over into the header file. It's going to be an outlet, and I'm just going to call it accuracy, and then I'm going to repeat that for longitude, and I'm going to name that longitude, and I'm going to do that for latitude. Okay, and connect. So we have each of these set up as properties because we're going to be taking content and putting them into these three text fields. So when we want to refer to them, we'll be able to say the latitude text and the longitude text and accuracy text. Let's also set up the map view as an outlet. So I'm going to right click and drag from the map view, and I'm just going to call it map view. Now there are still some things that have to be set up in the header file, but we're finished with the nib file. So I'm going to exit out of the assistant editor and go back into the standard editor, but go back into the header file. And that's just so that we have a little more room in here when we're editing this. Now we imported in the MapKit and core location frameworks, but our header file still needs to import in those files. So I'm going to import in the MapKit header file and also the core location. And so again, by importing them, we have access to all of the header files that's contained within those frameworks. We also have to add in the core location manager delegate. In other words, what's going to handle updating when the information comes in that there's a change in location. And we do that through the core location manager delegate. So as I even start to type in a C here, you can see the option that we have. So we're going to pop that in there. So this core location manager delegate actually defines the methods that are used to receive location and heading updates from a core location manager object. So we're going to also set up a core location manager object. So we're going to set it up with strong non-atomic, and the type is core location manager, and we're just going to call this location. With these other elements we were able to set up in Interface Builder, but we don't actually have something in Interface Builder that correlates with our location manager, so we're defining this here. Now, a core location manager object, this is creating an instance of the core location manager class, and this establishes when location and heading events are delivered and starting and stopping those events with your device. We can use the location manager object to get the most recent location and heading information, and then once it has that position information, we can start sending it back to the delegate, and then the delegate will handle that data and information coming in. Now this delegate is going to have a couple of other methods that we're going to set up in our implementation file, and we'll do that in a minute. So I think we have the header file pretty much set up, and we're going to switch to the view controller implementation file and begin setting that up. Now in our viewDidLoad method, that's where we're going to start working. So when our view loads, we're going to have it do some things with the location manager. So first we're going to create or add the location manager into memory. So self.location is equal to core location manager alloc and init. We're going to tell it that the location manager delegate is our self, since we added the delegate. So we'll say location delegate is equal to self. I'm getting an error here, and that's because in the implementation or in the header file we created this, but we didn't synthesize this in the implementation file. Right, when we do that directly from Interface Builder, it automatically synthesizes this, but when we type it in by hand, we have to remember to come in and synthesize other things that we add in. So now that error message goes away. Now some other things our location manager is going to do. We're going to say location desired accuracy, and that's going to be equal to a constant, and then there's several that are predefined, and we're going to say location accuracy best. We can see there are several different types here. Best for navigation, 100 meters, kilometer. And so these are different options. The greater the accuracy requires more time and power, so it can be a battery drain. The more accurate, because it has to keep sending and receiving constant updates. We're going to be doing location accuracy best, and this is the default value. And then we're going to say location distance filter, and that's also going to be equal to a constant called CL distance filter none. And the distance filter is a property of the core location manager class, and it's the minimum distance measured in meters that a device has to move horizontally before an update event is generated. So when we use the distance filter none, that means we're going to be notified of all movements. And again, that's going to eat up more battery power, but if you want more accuracy and constant updates, then this is the property to set. Next, we want to actually start updating the location. So we say location, start updating, and we don't want heading yet, we want location. So that starts the location manager sending and receiving information based on movement. And this will use these properties for desired accuracy and distance filter settings. And when it receives or when it obtains information, it notifies the delegate, and it's going to be calling some other methods that we have to implement for our delegate. So next, let's do that. So our location manager delegate is going to be looking for this method for when it gets update information. And this is called the location manager did update to location from location. And I'll pop that in. Did update to location with a new location from location, which is the old location. And so in here we're going to include information about getting the longitude and the latitude and also the accuracy. What I'm going to do is I'm going to paste some code in here, and then we'll take a look at an explanation of it. Okay, so I've added some code in here. Now again, what's going to happen is when our application loads and our view loads, we are initializing a location manager, defining our delegate as ourself, and specifying some properties for the core location manager. And then we start updating location. So it's looking for changes in position. Right? We have a high accuracy and we want constant updates when it's moving. So this is going to trigger the location manager delegate. And the location manager delegate, when it gets that information, it's going to execute this method. The location manager did update to location from location. So when it gets a change in position, this is what it's going to do. So we'll break this part down. This first part is going to display the latitude. So we're creating a string called lat. And so a string, initializing it with the format of a floating point number. And our floating point number is the new location coordinate latitude. Okay, so where did this coordinate part come from? I'm just going to click in here and open up the utility panel, and you'll see that it is a property from the core location. It's actually a core location coordinate. So it can get the value of the latitude of the current position of the device. So we create a string that contains that information, and then we tell it to go to interface builder and put that value into the text field. And really we're repeating the same thing again for longitude, and very similar fashion for accuracy. The only difference is instead of coordinate, we're able to do horizontal accuracy, which is a property of core location accuracy. So now if I run this in my simulator, okay, it says that our application wants to use your current location. So I'm going to click OK. You should always build something into your application though if the user says don't allow, maybe like pop up an alert like, okay, nothing's going to work in the app unless you do allow it. But we're just going to assume that the user is going to click OK. And here we have our accuracy, the longitude and latitude positions that's being picked up. Now your values are going to be different based on your location. Now so far we've just gotten this information. We haven't put it onto the map yet, so that will be coming up in a second. So before we put this information on the map, we're also going to put in another method that our delegate will use in case there's an error getting location information. So this is another void method, and it's location manager did fail with error. And so all we need to do is inside the curly braces put in what we want it to do if there is an error. So we're going to pop up an alert. And again, I'm going to paste some code in here to save a little time, and then we'll just go through and look at it for an explanation. Okay, so I've pasted in some code for our location manager did fail with error method. And first what we're doing is creating a string that just says error obtaining location, and then we have a simple UI alert that we are putting a title at the top that says error with our message in here that will say error obtaining location, and then it will show the alert. So in this case, this will only pop up if it can't find a location or it's unable to update. Okay, next I think we're ready to move on and add our location to the map view. So our interface already has a map view added. We did connect it in Interface Builder, so we're calling it Map View. So we'll refer to that when we want to address our map. And in our implementation file, okay, what we want to do is when the location manager gets updated information, we want it to be displayed in our map view. So this is where we're going to put in the information to update the map. So first we'll do the MK coordinate span, and this is the area that will be the span of our map. So we're just going to call this span, and we'll say span latitude delta is equal to, let's just say 0.01, and we'll say span longitude delta is equal to 0.01 as well. Okay, so the MK coordinate span is a structure that defines the area spanned by the map region, and it contains two fields, the latitude delta and the longitude delta. Latitude delta is north to south distance, and it's always about 111 kilometers, 69 miles, so that would be a 69-mile span. Longitude delta is east to west distance, and that can vary depending on the current latitude. At the equator, it's 111 kilometers, and it shrinks to 0 kilometers at the poles, so that will adjust depending on east to west distance, how far up north of the equator or south of the equator you go. Now, the smaller these values, the higher the zoom level. So if you want to zoom in really close, you make these numbers even smaller than this. Okay, next we have a map kit coordinate region, and this defines the portion of the map to display. So we're going to call this region, and it has two fields. It has a center and a span. So we'll say region center, and that's going to be equal to our new location where we just got to. We got this change information from our location manager, so we have our new location, and we're going to get the coordinate of that. And we also want the region to display our span, which is our latitude and longitude deltas, and that's going to be equal to our span that we defined here. And now we put it onto our map view, so we say map view set region, and it's going to be region, and we'll say animated true. All right, let's run this in the simulator and see what we have. All right, so here we have our longitude and latitude information, the degree of accuracy, and you can see how we are zoomed in here. Now, if you had this on a device and you were walking around with it, this map would adjust to show your location changes, because once that location manager starts sending location information, right, that's in our view did load, start updating location through our core location manager, then it will continually get updates. Basically, as soon as you move the device somewhere, that starts this location manager did update to location from location, and it will constantly show you the updated longitude and latitude accuracy information and update your map for you.